All right. By the end of this lesson, you'll know how to describe the differences and similarities between displacement and distance. All right. So a vector measurement. This is a measurement that describes both magnitude and direction. Describes both magnitude and direction. Okay, you guys, is Despicable Me in your childhood? Like the nerdy bad guy, vector, magnitude, and direction. Okay, so magnitude, that screen blocking. This is brutal, sorry. Magnitude is the amount, how much, the number of a measurement. Okay. So a vector measurement describes how much and in which direction. Good with that? Versus a scalar, this is a measurement that describes just magnitude. Describes just magnitude. Not direction. Some examples of that would be mass. Mass doesn't have direction, it's just a number, it's just how many kilograms there is. We don't really care, like, it's not like, what's your mass? Like 57 kilograms north. Like, what? Okay, or temperature is also an example of a scalar measurement. Okay, we'll learn lots of different vector measurements in this class. Okay, so in physics, measurements are usually broken up. Is it a scalar or is it a vector? Okay. All right, position. This is where an object is located, usually relative to a reference point or origin. Okay. In math class, x is the go-to variable, right? Like solve for x. In physics, different letters represent different measurements. Turns out that position, the variable for that is x. Okay, so if you're like solving for x, I'm thinking you're solving for position. Okay, so here, for example, person A has a position of -4 meters relative to this origin, and person B has a position of +7 meters from the origin. It's their location. Okay? Good with that? Okay. From chemistry, change in. What was the variable you used for change in? Remember that? Delta, it's that triangle thing. Okay? And when we are finding the change in anything, what are we doing? Calculate it wise. Something minus something. Super close. Final minus initial. Okay, final minus initial. That needs to be memorized because that's an always thing the rest of your life. Okay, the way I remember that, it's alphabetical order. Final, you always do final minus initial. You don't flip that around. Good? Okay, so that was a little bit of a review. Displacement is the change in position. The change in position. So to calculate that, we're going to do final position minus initial position. Okay? Good with that? Okay. Those are the factoids. Those are the facts. Okay? What's important is how to apply the facts. So, give this one a shot. Tell your neighbor what you think, what you guess.
And also, I just did the formula. It's on zero.
Correct answer is? Correct answer is B. The magnitude is the absolute value of a measurement. It's just the number. Okay? So in a question, if they ask for what is the magnitude of whatever, that should be a happy thought because you don't have to worry about positive or negative sign. You just need to worry about the number. Okay? It made your life a little easier. Okay? Next question. Tell your neighbor. Correct answer is okay. What I want you to do, I hear a split between A and B. I want you to find someone you disagree with and convince them that you're right and they're wrong. Tell them why.
That's 90.
But like,
Yeah.
you go with Florida, that seems like it's negative.
Yeah.
Okay. Anybody change their mind? Okay. Displacement. Final minus initial. What was your final position? 10. What was your initial? So your displacement was a negative 30 yards. Okay? If I ask for the magnitude of displacement, then that would be 30 yards. Do you see the difference there? Okay. Now, right here, this is a golden opportunity to learn. This is why I would recommend printing out the slides, is because if you got this right, great. If you got this wrong, great. This is an opportunity to learn. This is an opportunity to say, okay, I thought it was A, and then it's not because, and you're writing down what you learned. It's kind of like a log entry. You have a certain scenario and you learn something through that. Does that make sense? And so the slide right there gives you the context. You don't have to like try to like recreate the scene. It's like right there. And so when you go back through, you're like, oh yeah, that. Okay, does that make sense why that recommendation print out the slides? Okay. All right, so same scenario, but what is the distance? It's the same scenario. Okay, so here's how I want to run the class here. When I post a question, I want you to read that by yourself and answer that independently of anybody else. Okay? If you are a verbal processor, I totally get it. Just hold tight. You'll have an opportunity to verbal process momentarily. But I want everybody to independently, as if you were taking a test, try to answer that question without influencing or being influenced by anybody else. Okay? Once you have that, an opportunity to answer that independently, then I'll let you talk. Thumbs up when you've got something. Have a conversation. Okay. What do you say? A is the correct answer. Good with that? Okay. Here's another just point of reflection. If you find yourself in a neighborhood that's not very communicative, like you're not talking very much, you can either like step out of your comfort zone and knock on some doors or like move to a different neighborhood. Most of lecture time is spent conversing like this. So you need to be in a good neighborhood that's going to foster that. Does that make sense? Okay. So, what communicates direction that we just saw? Mathematically, what communicated direction? Ben? Positive, negative sign. Okay. Can distance be negative? No. So is distance a scalar or a vector? It's a scalar quantity. Can displacement be negative? Yes. Is it a vector or a scalar quantity? Vector. Guess what we prefer in physics? Displacement or distance? Displacement. Why? Because it has more information. It tells you how far and in which direction you're going. Good with that? Okay. Here's another scenario. Thumbs up when you got something. Tell your neighbor what you think.
You go from, because you start at 20, then you would minus, and this is
Okay, what do you say? Correct answer is B. I like it. Okay. Final position was 30 minus initial position 20. Okay. Same scenario. What is the distance? Do not influence or be influenced. Hang tight to your thoughts. I know it's tempting. I was want to say something. Just hold fast. Now talk to your neighbor. Tell them why you think so. Correct answer is. Everybody go with E? Okay. So looking at the distance traveled. Okay. Looking at, bless you, your feet. Okay. Ever run track? One loop is 400 meters. Tell your neighbor. Correct answer is 0. 0? I'm exhausted. What do you mean 0? Why is it 0? You didn't go anywhere. You ended up in the same spot to where you started. Okay? Now, you did burn calories. That's a function of distance. But accomplishing anything, you didn't in terms of changing your position. Good with that? Okay? So, I want you to put in your own words, we've seen several different examples. How would you compare and contrast distance compared to displacement? Distance and displacement. What are the differences? Bless you. Okay. So hopefully that was in your there's a lot of research done that says when you put things in your own words, you remember it way better than you transcribing something that I give you. Okay? Hopefully what you put down, like what I put down and what you put down, like it captures the same ideas just in your own words. You okay with that? Okay. I guess you could say only positive could be positive or negative. Okay. Good. Okay. Last couple things here. Clock reading. This is a moment in time. Okay, clock reading, a moment in time. This is like a point on a number line. How long in geometry, what's the length of a point? None. Just a placeholder. Okay. How long is a clock reading? It's not. It's just a moment or instant. Okay. And the variable we use for that is a lowercase t. Oh, bah, to be continued. Ah, so close. No homework tonight. Actually, finish this off here. Time duration. Let me finish.
Is there a lot of homework for this class?
I'd say 3 to 4 assignments a week.
Alright, that's fine.
This is a change in clock reading. You too? So it is final clock reading minus initial clock reading. And usually our initial clock reading is 0 if we use a stopwatch, but yeah, delta t is how long of a time. Okay, there you go.